Hello guys, welcome to another episode of Sound Talk Show. Today we are going to do Advent of Code, Day 4 problem. Let's do Day 4, okay? I haven't read the problem yet, but let's get on. So today's talk show, let's start code, Wolfram language. Okay, so pop it out, and I have Wolfram language started there. And day 3, I haven't finished yet. I can finish it quickly, but I didn't realize that you can jump to different days of the problem. But anyway, let's get on with day 4. And today I try to do as fast as possible and basically just finish it in 30 minutes or an hour. Okay, let's hope we can do that. Let's see if I can do that. So, don't worry about fancy, I want to create the shortest code of all programming languages. Now, that is trivial in Wolfram language. If you've been coding Wolfram language for a year or two, any of these problems, you just go with the simplest solution, the first solution that comes to your mind. That solution is going to be the shortest of all programming languages. Now, actually, possibly except APL, okay? APL, the hot dog, just mentioned APL. APL is, you cannot beat it. You can, kind of, but depending on the problem. But anyway, but if you want to create a Wolfram language solution that is the shortest among all other Wolfram language solutions, then that is the difficult part. Okay, so that is, that is a bit more difficult because you are competing. Anyway, let's get on with day 4. Okay, so day 4 problem, I haven't read it before. Let's see. The gondola takes you up. Strangely, though, the ground doesn't seem to be coming with you. You are not climbing a mountain. As the circle of snow island recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of the new island and lurches into the station. Okay, as you exit the gondola, the first thing you notice is that the air here is much warmer than it was on Snow Island. It's also quite humid, warmer and humid. Is this where the water source is? The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colorful square cards. Okay. Oh, hello, the elf excitedly runs over to you. How may I be of service? You ask about water sources. I'm not sure. I just operate the gondola lift. That does sound like something we'd have, though. This is Island. After all, I bet the gardener would know. He's on a different island, though. The small kind surrounded by water, not the floating kind. Okay. We really need to come up with a better naming scheme. Tell you what, if you can help me with something quick, I'll let you borrow my boat and you can go visit the gardener. I got all these scratch cards as a gift, but I can't figure out what I've won. Okay, now there's a link, some annoying link, probably to, Wikipedia. Scratch card. Yeah. Okay, so he's got a bunch of scratch cards as a gift, but I can't figure out what I've won. Okay, the elf leads you over to the pile of colorful cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. Pick one up. It looks like each card has 2 lists of numbers. Each card has 2 lists of numbers separated by a vertical bar. Okay, okay, a list of winning numbers and then a list of numbers you have. You organize the information into a table, your puzzle input. Okay, I'm not sure. Okay, so let's just put it down here. Each card has two lists of numbers, so there are two lists. Each list is a list of numbers separated by vertical bar. The vertical bar separates these two lists. So the first list is a list of winning numbers. Then the second one is a list of numbers you have, okay? List of numbers, winning numbers, and the list of numbers I have on each card. And you organize the information into a table, okay? So then, as far as the elf has been able to figure out, you have to figure out which of the numbers you have appear in the list of winning numbers. The first match makes the card worth 1 point. And each match after the first double the point value of that card. So double is like multiply by 2. Okay, for example, so here is probably your input. So let's okay, so that's the string input equals true. Okay, okay, yeah, so a bunch of cards, and let's just make it like that. A bunch of cards, each one has a two list of numbers. Okay, the first part is winning numbers, the second part is your numbers. Okay, then you want to match them up. Now if there's a match, you get 1 point. Now if there's a second match, you double your score. Then third match, you double it again, probably. Okay, in the above example, card 1 has 5 winning numbers, 41, 48, and so on. Can you see it? Oh shit. So what is the importance of ergonomic design? Is Wolfram poetry? Is this okay? So shit posters go away. Okay, so we are doing Wolfram. Advent of code. So here's the problem. Advent of code day 4. So right now, so you have. So this is the card. You are giving a bunch of cards. Each one has two lists, a list of winning numbers and list of your numbers. In the above example, card 1 got 5 winning numbers, 41, 48, okay, and 17, okay, and 8 numbers you have, okay, something 53, okay. Of the numbers you have, 4 of them, 48, 83, 17, and 86 are winning numbers, okay. Check 48, check 83, check 17, check 86, check, okay. That means card 1 is worth 8 points, 1 for the first match, then double 3 times for each of the 3 match after the first, okay. So it's a geometric progression. Wait, yeah, so it's 1 plus 1 times 2 times 2 times 2. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So 8 points, that's right. So the formula is basically actually we can write this in Wolfram language, product, and the product is x times 2, x times, basically you want 1 times 2 times 3 times 4, okay. So let's just, so x goes from 1 to 4, okay. So basically that's it. We can actually run it. No, this is 1, 2, 3, 4. So this is product of 1 times 2 times 3 times 4. That's not what you want. What you want is you just want power. So 2 raised to the 4th power, except the first one. So 2 raised to the 4 minus 1. So you got 4 winning numbers minus the first one because it starts with 1. Something like that. It's 8, right? So that's kind of the formula. Okay, so 4 cards, you won 4 numbers. So you minus 1 and 2 raised to that power. Okay, that's basically how you get the score. So card 2 has winning numbers 32 and 61, so it's worth 2 points, and so on, and blah blah blah, worth 1 point. Okay, and card 5 has no winning numbers, so 0. Okay, so in this example, the elf profile square, so the answer is 13. So the answer is 13 for this problem. Okay, how many points are there worth in total? Okay, let's get your puzzle input. Very easy trivial problem. Okay, let's say advent x advent, let's say 4. Okay, let's just say that for now. Okay, magnify, show space. Okay, 202 lines. Okay, this is a trivial problem. Okay, copy the file path, close it, shrink the window, and input equals to read string this file path. Now to be sure, let's see what is the documentation for read string. Okay, so we are correct. Read string and the file path. Yeah. So okay, so remove that, and we can run. Let's see, we got the input. Okay, so yeah, so that's correct. So we got it. So very trivial problem. Okay, let's see if how fast I can finish this. Now the Sam Nasty guy, you're gonna get banned. So okay, so yeah, so you got so you got the first bunch of numbers, you got second list of numbers. You want to compare which was very easy, trivial. So let's start to do it. I'm gonna member queue. So member queue takes a list. Okay, so let's say the first member queue takes 2 items. The first one is a okay, actually you need to parse it because some of the numbers got two empty lines. Yeah, okay, but let's go on. Let's show the algorithm here. Okay, so that's a list, and then you have a second list. That's the winning numbers. Okay, then you got the card number. Okay, so these are the winning numbers. Am I good? Yeah. Okay, so I believe that we'll just return the list of matching numbers. Members, okay, the documentation, return true if element. No, we don't want member queue, we want subset of match. Okay, so let's see. So you have union, intersection is you want, so you don't want member queue. So intersection is the function name, not interval. Okay, let's look up documentation for intersection. Intersection, a bunch of lists, give a sorted list of elements common to all. That's right. So intersection to list, okay. first list, second list order doesn't matter. Okay, so let's run that. Okay, so the result is 4. So okay, so we already almost solved the problem. So what you want to do is you just split string, string split. Okay, string split. Okay, the naming of the function in Wolfram language. String split of input and split by lines. Okay, so that's new line character. So input 2. Okay, so let's just say that. Then you map each. Okay, so okay, I'm gonna make sure I finish this problem. So map input 2. So now you got a bunch of lines as a list. For each one you want to split. Okay, for each one you want to split now, this time by that vertical line. Okay, yeah, so this way we'll give you 2 parts. Okay, let's just do this quickly. Input 3 equals to, okay, so let's run them. Okay, let's run the whole thing. Run it. Okay, you forgot something. I forgot. So here this is a function, so we need to put a ampersand, meaning that's a function. Okay, so intersection, this one we don't need. Copy all, select all, paste, run it. So we got, oh god, that's too much input there. That's because we, oh yeah, let's work with the where's the read string? Oh yeah, let's work with the short input. Okay, so input, then split string, then input 3, copy all, select all, paste, shift enter. Okay, so we got so here is, let's see, so now let's see input 3. We want to take the first element. Okay, exactly. Now of the first element we want to first element, then take the first element of that. Okay, correct. Then okay, now so far they are all strings. Each element is a string. Okay, no problem. So now we just intersect. Okay, so let me do this. Okay, line 1 equals to input 3, the first line. Okay, that's right. So now we got the line 1. So what we do with line 1, we just apply the intersection. Okay, so intersection line 1 first part, line 1 second part. Okay, non-atomic. Wait, why is it non-atomic? Non-atomic expression expected. So what is line 1? Oh, you split you right now it's each line is a list of 2 strings. So you need to split again so each string becomes an element. Okay. Let's just use the simplest way to solve this. Okay, let's worry about efficiency later. So right now, so you just split by white space, so you don't need, so line 4, input 3. Okay, now each element is actually an element. Okay, so now there it is. That's line 1. And now intersection. Fantastic. Okay, so that how many, so you just calculate the length, of that, then you just apply this formula. Okay, so this formula is 4 is the length. Okay, so let's length at argument. Okay, so that is a function there. So that is a function. Apply that function to this. Okay, 8. Okay, so that is score for line 1. Now all you have to do is just do the same thing for each and every line. Okay, now let's see if I can make it one shot without trial and error. Anyone else is watching? Concurrent viewers 9. Okay, say hi if you are here. Okay, stream's current bit rate is lower, blah blah blah. Okay, success. I'm just gonna make this one line, single line solution without trying again. Okay, so here are the solutions. So okay, so the input, so we you want to, okay, so function map at input. Okay, so the function will be so first of all split it by new line. Yeah, we need to do that. First you split by new line, then you need to split again. You need to split like 2 more times. Okay, let's put it here. Am I doing good? Yeah, I hope so. So the second time you need to split by that. Okay, so there. Okay, so actually let's see the documentation. We want the, is there a functional notation? No, you don't worry about what I'm saying. I'm trying to get shorter notation. Okay, no functional notation. I'll just write it this way then. Okay, so that's function. Then you split again by space. So you don't, by default it split by space. Okay, so basically this is a function. Okay, you have that, then you apply this function. So basically, let me show you. Okay, so you map this function to the input. Then what this function does, is that it's split by new line, then split by the vertical line, then split by white space. Okay, so in this case you don't even need that, and you don't need the parent neither. And I'm pretty sure it'll work, but I was saying I'm not going to do any trial and error. But anyway, so once you do that, what you get is the nice input, a list of lists. Then you apply this function. So you got this whole thing. Then what you do is okay, let me show you. So this whole thing, put them inside the paren. Then what you do is you apply another function. So this is a function you want, line 1, line 2. Okay, so you want, let's write a function, and this function will take okay, so let me get fancy here. Let's just do that. Okay, so you take the first part and the last part, then do the intersection. Then what you want is the length of that. Okay, so length at, okay, apply the length function to the result. Then out of that you basically do so this is, I'm getting very fancy here. So you get the length of the intersections, which is the total number of the count of the winning numbers you have. Then -1, then raised to the second power. So this is a function. So you apply this function to that input. That's right. So there, map. There, that's solution. Oh wait. So what you get once you get that is you get a list of numbers. Each number is your score, and all you have to do is you sum them up. Is that right? Worth in total, how many points? Yeah, you just sum them up. Okay, so sum is total. Okay, that is a solution. Let's try it. Non-atomic expression. Okay, I got it wrong somewhere. Failed. I failed in this blind coding. Okay, so we'll have to see. So let's be more careful here. So let's try this part. Yeah, so that is the nice input. Each one is Wait, what exactly is that? Yeah, I'm not sure what exactly is this. X equals true, okay? So now take the first part and see. What? Part specification is longer than depth of object. What do you mean? What? So we map this function to the input and yeah, fuck. High Q intent. So so what is our input? Did we screw up the input? Input. So the input input is the input a string. Yeah, the input is string, and okay, let me finish this. So the input, oh, you're not at, not map to. That's right. That's right. So this is actually not map to. So, okay, so I got it. You don't need to map. You just put the input here, okay? So you put the input there and okay, so let me just work this out. Okay, maybe that's the solution. Huh? Wait. We copied, we didn't copy the whole thing. Okay, no. Close. Okay, so you need a map here. That's right. So let's try it. 14. Am I correct? Please. So in this example, the elf's pile of scratch cards is worth 13 points. I got 14. So something is wrong somewhere. Okay, let's remove the total. Let's see. Where does the half came from? Okay, so last two lines. Something wrong with the last two lines. Let's see. why is that? Let's just try to fix this. Okay. Let's see what is our exact input here. Plus, why are we getting the plus? No. Oh, okay, wait, total. Okay, we want to see what this line does. Here is what is wrong. Oh yeah, you need a map. Why is it? I have a, you see, I have a slash here, but it's no slash there. What's going on? Yeah, so this is what I expect. That's right. And each one of them is a string, each element. Okay, so this should be the solution, but why? So let's see, where did we got it wrong? Okay, so now this is the solution. Now let's just compute. Let's see. Let's just map that to this input. Right. So 4, 2, 2, 1. So that's a number of match. Card 1 is 4 match. Card 2 is 2. 4, 2, 2, 1. That's right. So this is correct. Now now 4, 2, 2, 1. So now if you apply this multiplication, this 2 to the power, why is it you see, we apply this function, we map this function into the last output. Oh, so when it's 0, you become that's why the power is wrong. So you got a 2 raised to a -1 power, so that becomes 1/2. Yeah. So what you want is so when it's 0, you ignore it. When it's 1, result, yeah. So when it's 0, ignore it. So that, you know, we can easily do a if expression. Yeah. So okay. So you know there are many ways to do this, but let's Yeah, okay, let's do this. Okay, delete cases. Okay, now let's say this is the input and 0. Okay, minute. Yeah, so we can just apply that there. So okay, let's look up the documentation. Let's see if I can put it in a into a operator form. Yes, you can. Okay, fantastic. So I'm just going to say delete case is 0, then add. Fantastic. So here is a solution. Wait. Okay, here is a solution. What? Oh, okay, you forgot to, yeah, so you got a operator precedence wrong, so you need to actually, let's see, operator precedence. Yeah, so this part needs to be parenthesized. Okay, what? Oh, you forgot. Wait. Oh, you need to apply the delete cases after the intersection, obviously. Okay. No, after the length. So you do the intersection, then you do the length of them, then you do the delete cases, then you raise to the power. That's right. So now you just say total. Okay, so I think this is it. Why is it still 14? Jesus. Is it 13 or 14? 13. Yeah, something is wrong. Okay. Intersection. Length. Okay, so yeah, so this is okay, so let's do it here. So you do that, you map them, you get a bunch of intersections, then you do the delete cases at, okay, at the whole expression. Okay, then you you need the length first. Okay, you got a bunch of intersections, then you need to so you need to put here, then you remove the 0, then you apply this function 2 to the power. Okay, I think that's it. Now let's make sure the operator precedence is correct. Okay, once you got that, then you apply delete cases, then you apply the map, then you get the total. Okay, so I think that's it. Now you need to 13, fantastic. Okay, that's the solution. Let's clean up the code. How many minutes? 47, not too bad. Could have been better, but okay, not too bad. First of all, so let's restart. Now let's load our own input. Okay, run it. That's our own input. Now let's just run this code. Shortest solution possible. Okay, you didn't need to put that there. Okay, run it. 23235. Are you sure? I'm sure. Let's see. Okay, so you need to copy it. Copy. Answer. Are you sure? Yes, shut the fuck up. That's the right answer, of course. Okay, Sam says a bunch of things. What is the purpose of parser? Is your code base? What is the best way? How does CSV? How does that CSV work? How does that CSV work? Which aspect of that shorthand operation works with the... Oh, okay, so in what case does this apply in regular expression and file organization? Great content in channel. I don't know what you are saying. Are you trolling or what? I don't know, Sam. What are you saying? Okay, you're like a parser. Okay, I don't know if you are trolling or not. So anyway, so here is the solution for day 4, problem 1. Okay. Of course, one-line solution, we can make it shorter. Now, how many characters are there? $150. Can you make it shorter? Yeah. Let's do it. Let's try 2 minutes. Okay. I don't want to be stuck with this, because usually that's what I do. I stuck with this. Making it shorter. So. Can you make it shorter? Yeah. So first of all, and first and last length, and for example, we can save 3 characters by just putting this part into the cases. We save 3 characters because now I don't need the extra paren, and this paren I don't need anymore because now, so let's remove it. This is what all this is silly, because there are many ways to determine what is the shortest solution. And a better, typically in a C idiots coding word, the shortest solution means the least number of character count or the byte count. That's the most idiotic concept. So a better concept is actually you count the number of tokens of that language, so that if you solved one problem, but however your function name is 100 characters, that only counts as one. In other words, function name shouldn't count as like into the shortest or longest. So you should count tokens. And even a better idea in Wolfram language is they count number of leaves. So anyway, so here is kind of shorter, but you can you make it shorter still? Yeah, for example. Anyway, let's not worry about it. So let me show you the token idea. So you can leaf count, okay? So there is a leaf count. So given this thing, you can count how many leaf. So, Wolfram language expression is like Lisp. It's a, you can think of it as a tree, abstract syntax tree. In fact, any language automatically become that when you compile, even C. So when you have a tree, any expression is a tree. So you count the leaves, okay? That's what this leaf count does. So let's show you, I can show you. So what you have to do is you have to say hold. Otherwise, this thing is gonna evaluate to a number. And then leaf count is just 1. So you have to hold, then, then this is our input, then leaf count 31. So this is a typical way in Wolfram language coding competition, how you determine if a code is shortest. You do the leaf count, okay? Now, of course, in other languages, you don't even have that. You have to, it's like, to write this leaf count takes how many lines? Few hundred, because more than, because to do that, first of all, you have to write the parser of the language first. Then you got the abstract syntax tree. Then you can count the leaves, okay? So, but anyway, if you don't have leaf count, usually you can just do token count. I mean, in most other languages, since their names are not symbols like Lisp, so in C, in Java, in Python, you can't even do token count because you have to pass your source code first in order to determine what's a token. Then you need the token grammar. And anyway, but a simple way is you simply count each word as a token, separated by space. That's a kind of cheating. I mean, that's a sloppy way. So anyway, so that's a solution for day 4, number 1, okay? Okay, Sam, one more message, one more trolling message from you. You get banned, okay? So today is just Sam. So you people here say hi, okay? So Q in 10. Anyone else? So anyway, that's a solution for day 1. So what should we do? Should we continue to part 2? Let's see. We are 15 minutes. Why not? Okay. Okay. So let's So this is good code. Yeah. And this part is code explanation. Okay. Then put the code explanation at the bottom. Then that's it. So that's our solution. Advent of Code 2023, day 4, part 1. Okay. Now let's put it back. Let's syntax color it. So there is today's solution. Now day 2, let's see if we can do part 2. Let's see quickly. I'm gonna give it 10 minutes, no more. Coffee, let me stretch for a minute. So part 2. Just as you are about to report your findings to the elf, one of you realizes that the rules have actually been printed on the back of every card this whole time. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards equal to the number of winning numbers you have, okay? Specifically, you win copies of the scratch cards below the winning card equal to the number of matches. So you win copies of the scratch cards below the winning card equal to the number of matches. Oh, okay, so let's say you have one of the card. Let's say there are 3 matches. So that means you go down 3 lines, something like that. So for example, if card 10 were to have 5 matching numbers, you would win 1 copy each of cards 11, 12, 13, 14, 15, okay? So you go down 5 of them, grab the next 5 of them, okay? So check number of matches. Suppose it's n, then you grab the next n cards, something like that. Okay, score like normal scratch cards and have same card number as the card. So if you win a copy of card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original card 10 won. What? If you win a copy of card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original card 10 won. What the fuck? What do you mean? Card 11, 12, 13, 14, and 15. This process repeats until none of the copies cause you to win any more cards. Yeah, fucking idiotic. This time, the above example goes differently. What do you mean differently? Okay, they changed the input. I'm not really happy with the advent of code. So this day 2, typically they don't change, the input. So, because when you design a puzzle, you should stick with 1 or be consistent. So anyway, so here is the input. So the example input, is it the same or not? It is the same. 19, 1, 11, 83, 36, okay. So what do you mean this time the above example goes differently? Card 1 has 4 matching numbers, okay? So you win 1 copy each of the next 4 cards, 2, 3, 4, 5, okay? Your original card 2 has 2 matching numbers, okay? This one. So you win 1 copy each of card 3, 4, okay? Your copy of card 2 also wins 1 copy each of card 3 and 4. What? Oh, so what? So the copy of card 2 also wins. One copy of each card 3 and 4. It doesn't make sense. So let's go on. Your 4 instance of card 3, 1 original and 3 copies. Oh, Jesus. Your 8 instances of card 4. So I got 4 instances of card 4. 1 original and 7 copies. Have 1 matching number, so you win 8 copies of card 5. So the idea is that now each card has a multiplicity. This multiplicity is determined by preceding cards. Okay, and okay, but what is the score though? So your 14 instances of card 5, 1 original and 13 copies, have no matching numbers and win no more cards. Your 1 instance of card 6, 1 original, has no matching numbers and wins no more cards. Okay, what is the problem? Once all of the originals and copies have been processed, you end up with 1 instance of card 1, 2 instances of card 2, 4 instances of card 3, and 8 instances of card 4, and 14 instances of card 5, and 1 instance of card 6. Okay? The instance means multiplicity, and that is determined by previous cards. They are matching numbers, kind of. So in total, this example pile of scratch cards causes you to ultimately have 13 scratch cards, counting the original. So basically, the problem is the total of multiplicity. Okay, seems easy. Total of multiplicity. Process all of the original and copied scratch cards until no more scratch cards are won, including the original set of scratch cards. How many total scratch cards do you end up with? Okay, this problem is just multiplicity and very easy. We just very easy. Each card, instead of saying card, we just call it line. The fucking do away with the elf problems. So get the total of multiplicity of each line. So the multiplicity is determined by, that's hard to explain. It's better to explain in another way. But let's not explain it. Let's just do it. Okay, so we don't know the answer. So just like before, we got this we need this part for sure, just like before. Okay, wait, we don't need the total. Okay, screwed up something. What is it? What? Oh, this is the total. I mean, that's not the total input. We want the total input. Okay, total input. Okay, then evaluate this part. So yeah, so that's the number of matches per card. So once you got this, you want to count multiplicity. Okay, so which is easy. You okay, so you okay, so you want multiplicity. So the first one, so basically, first of all, you want map indexed. Okay, you don't need the powers anymore. You want map indexed. Okay, map index takes two arguments. The second is a list. The first is a function of two arguments. Okay, the first argument is the element in the list. The second argument is the index of that list. So this way we know which number is which card. For example, if this is, this first line is index 1, second line is index 2. Okay, do we need that? We kind of need. So hold on a second. So let's see. So each number means go down the next two. Each number means go, grab the next two lines or next n lines. Okay. If you don't, let's don't worry about efficiency or anything. Let's just do it quickly. It's very easy. So you just so you just, in this case, you don't want delete cases. No. Let's try that again. Let's see what is. Yeah, so this is the input. So let's say xx equals to that. Okay, this is the main input we want to work with. Let's name it xx. So then you map indexed to xx such that the first argument is the number of the next cards. Okay, so you want to take the multiplicity. Okay, so maybe you need some kind of recursive solution. Do you? Or can you just map index? Let's see. If you use map indexed, you get this. So let's say the first line means grab the next 4 lines. Each one of them their winning number count must increase by 1. So what is it you are trying to do? You are trying to, so there are quite a few ways to do this. So how do you, so for each line you get a number, which is a number of match. For each line you get a number. This number is the number you want, plus how many times this card has been selected by previous, that is the multiplicity. So ultimately you want this number times the multiplicity. So ultimately, this is a key. Ultimately, your solution is that for each line, you have a number, that's number of match, multiplied by the multiplicity of that line. Okay? Then you sum all these together. A number of match multiplied by multiplicity of this line. Then you just sum all the lines together. Okay, so now the number we know, the number for each line is just, this solution. The problem is to get the multiplicity. So we have to determine the multiplicity for line 1, the multiplicity for line 2, and so on. And the way it is defined is by Can we just use a map, or do we have to use recursion? Let's see. The multiplicity is defined by, for each line, if there's winning number, if there's 4 match, then that means the next 4. That means you add 1 to each of the next 4 lines. Okay, so you cannot, like, in one shot get the multiplicity of a line, because when you process each line, they indicate which the next n lines should increase their multiplicity. So what you know that, so first of all, what you know is that okay, so if this line number is 4, the number match is 4. That means the next 4 lines, each one gets, multiplicity gets incremented. So yeah, you can use map indexed. So okay, let's define multiplicity list. Okay, let's see. No, that's not what we want. That's what we want. Okay, so to begin with, this list indicates each line's multiplicity. Okay. I'm getting tired. Okay. Let's see. Okay, I want to finish the problem. My back hurts because I'm getting old. So multiplicity, that's the thing you want to compute. So you map over that. So each number indicates the next n lines. So you can directly add equal. That's right. So multiplicity. So what you want is map indexed. Okay, that's better. So multiplicity equals to that. What's going on? Don't tell me. Yeah, okay. So this is better, okay? This gives you the multiplicity. The initial, okay? So then we map indexed. We want to focus on that part. So when it's 4, so the map indexed, when it's 4, that means you increment each that means you the current index. So the argument 2 is the current index. The current index hello X29. Okay, what's the some of the approaches? Let me think about again. What we can do is let me just show it. Okay, so if you run this is what you get. What? Oh yeah, but yeah. So you cannot do that. The second part is just the index. So the multiplicity of a line each give you the next 4. So essentially so you need to okay, so let's do this. So each one you get that, and you want the table. Okay, so you want the table. So if you get number 4 here, you want it to return a list of the next 4 indexes. So for example, this number 2 for the second line, you want it to return 3, 4, meaning grab the third line and fourth line. Okay, so for these 2 on the third line, you want it to return 4, 5, because this 2 is on the third line. So 2 numbers after third line is 4, 5. So this number 1 is on the fourth line. So 1 means grab the next line, so it returns 5, meaning the line 5 just line. So each of this number you want it to return a list of the numbers. That's kind of the, yeah. So we can do that, but okay, let's just focus on a simple solution first. So each number you, okay, easy. Range that plus. Okay, it's so easy. Let's see. Yeah, so that's what we want. Let's see if we, okay, something is wrong. Oh yeah, you cannot add 1, can you? No. What? You can. So why can't you? Oh yeah, so you need, yeah, because the, when you map indexed, when you use the function map index, it doesn't return just a single number for the index. It actually returns a bracket, because that way you, because Wolfram language is, everything is a tree, unlike Python or others where a list is usually flat. So anyway, so this will do the trick, you see. So compare, we're going somewhere. Okay, so compare the input, so we don't want this part. So you see, we are working on this input. This is a number of match for each line. So we want to turn this input into this input. Okay, so then once we have that, for each of these, we just add 1 to the index, yeah, to the multiplicity. Okay, where is the multiplicity? Here. Right, and then we just do, okay, then we map over this to the multiplicity. So then we go over this list for each number. That means increment the multiplicity. Okay, so we don't even, we can just do a count. Fascinating, that's right. So we don't have to add 1, add 1, add 1. We just do a count, sum them up here. So yeah, that's easy. So you got this bunch of numbers, you want to unique and count. Okay, so so for each of these number, the number indicates the index, the line number. You want to uniquefy and count unique occurrences of each. Then that result you just add to the multiplicity. Okay, so how do you, what is the function for unique? So this is no good. Yeah, unique elements. Let's see. Unique elements list gives an element for each list that are not in any other list. Okay, so that's not what we want. What we want is count duplicate. Something like count duplicate. Okay, bound count, byte count, character count, count distinct. There it is, count distinct. That's it. Okay, so what? Oh wait, so this copy the input, put the input here. No. Oh, count distinct gives you a number of distinct elements, but what you want is their duplicity. Okay, let's see count distinct. Let's see the documentation. If there is options, you see, that's right. Count distinct by, delete duplicate, delete free, counts, count distinct by, gives a number of distinct values. So this function count distinct by is you apply a function first. Use the function to determine distinctiveness. That's right. For example, you can see from this example. That's count distinct by. Yeah, so in this case, distinct is just 2, A and B. That's right. So this is not the function we want. We want, let's see, count distinct. We don't want to actually count the distinct. We want to count each duplicate, okay? We want to count the duplicate. So let's see, delete duplicate. Okay, so delete adjacent duplicate, delete duplicate by. Partition. Okay, let's see, partition, no. We want to group by. Okay, so let's see, gather. So gather the element of list into sublist of identical elements. That's the one we want. Gather. How nice. That's why everything is so short. Gather. Okay, so gather, this is the input. Let's try it. Yeah, that doesn't work because we need to flatten the list first. Okay, that's right. Now once you have that, you can simply count the length, map a function, just count length and we are done. But is there a simpler, like we can skip this step if there's a simpler function, a built-in function such that it gathers the distinct elements together. But not just that, we want is that we want to count the number of distinct elements. Gather element into sublist into identical list. Okay, so So is there a shortcut? Group by, merge, tally. Tallies is the one. That's right, there it is, tally. You see, that's why Wolfram function is usually programming in Wolfram function is a matter of finding the right function. Because there are 7,000 functions by default. You want to spend your time. This is exactly what we want. So so what is this? 5 occurs 3 times, 4 occurs 3 times, 3 occurs twice, 2 occurs 1 time. Exactly. So tally is what we want. Okay, let's get on with this. Let's tally. Okay, so let's just copy that. Tally something. Okay, we want, so xx is, we have xx. Okay, we have okay, we have multiplicity. Okay, then we map that into xx by what was the function? Oh yeah, the function map index. Oh yeah, there. Yeah, so let's try again. That's right. So we got that, and then we flatten it. We don't need it nested. We can flatten it. Then we can tally it. Okay, so this just make it very short. Flatten tally. Then we map the whole thing to the xx. Okay, so let's write out. Okay, map a function to xx, and the function will be so actually, so we got this list, and so we map a function. Yeah, we do need to map a function. Map. Okay, so the second part is a list, which is that. The first part is a function. Okay, let's write the full form way. Okay, so it's easier to understand for everyone. So we write the function maps to that. The first element is the line number. That's right. So the first element is the line number xy. The second element is multiplicity. Okay, then all we have to do is we this is not functional approach, but we can just code it. multiplicity list. Am I doing good? Yeah. It's kind of boring. Okay, so this equals to let's say dupe. Kind of like that. Okay. Okay, something wrong. Too many parameters in line number dupe. What? Oh, yeah, because this only take, yeah, that's right. So you only take one argument. Okay, so line number is x, the first one. Okay, and duplicity is x second. Okay, like that. And what is that? That, and yeah, so the result doesn't matter. What we want is the multiplicity list. Okay, then just total. Okay. 13 again. No, it should be 30. Okay, something. Did we do it right? Okay, let's see. Okay, this is not good. Actually, there's so much better ways to do this. Yeah, but I have to think. So we don't want this. We don't want define. We don't need to define variables. Multiplicity list. Bad idea. So we can simply map indexed. This is good. That's right. And for those, that's okay. Let's clean this up. Tally gathered count distincts. Very interesting. All very interesting. Okay. So this is all we need. This is the key. Okay, this part is the key. So let's put out the important things. Okay, the important things is this part, and then Okay, but before we do that, okay, so each one of those are index, and if they are empty, if it's 0, what you get with range 0? I think you get 0. Oh yeah, you get empty list. Okay. So what we want is okay, so you do that, then if it's 0, you want if it's 0, you don't care. If it's 0, that means so does this count the non-winning scratch cards? Once all of the originals and copies have been processed, you will end up with 1 instance of card 1, 2 instances of card 2, and something card 3, 8 instance of 4, 14 instance of 5, and 1 instance of 6. In total, this example pile of scratch cards causes you to ultimately have 30 scratch cards. So even those scratch cards that is not a winning card, you also count it. You count it as 1. Okay, that's why we have an arrow here. So even the card doesn't have any winning numbers, you also count it. Because all you want is number of copy of scratch cards you have. So what we want here is, okay, we modify this expression. Map indexed, okay, if equals to 0, if the winning count is equals to 0, then you simply return the the index of that card number. So here is 2. Otherwise, that's right. So let's make sure we are correct here. We don't need paren. That's right. So this is better. So you see the 5th line, you get 5, because even though it's not a winning card, but you still count it 1 time because you got that scratch part. scratch card. Same thing for number 6, right? So once we got that, then we tally. You see, then we then what? Then we yeah. So what this means? So this means the second card has one multiplicity. The third line has 2 copies, instance. The fourth line has 3. The fifth has 4. Let's see, 1 instance of 6, that's right. 14 instances of card 5. So this is incorrect. God. Hello, finally someone's here. How's the problem coming along? Hello, Ksa, Merry Christmas. Hello, Tiago and Lunita. So we are doing day 4. We solved the first part easily, and now we are on the second part, which is also easily solving it. But now it's like 50 minutes. Okay, so but we are close. We are not stuck in somewhere, but it's just okay, close. So yeah, we need to stop. This is 2 hours now, but let's finish this. Okay, we are very close. So now seems we are wrong. Why is that wrong? So this part means the first card has 4 matching numbers. The second card has 2 matching numbers. The third has 2. Okay. Now this part means, oh, okay, so you forgot. It should be 1. That's right. Yeah, okay, so that's stupid. Yeah, that's what we want. That's the format. Wait, why is it just... What? If it's 0, if it's 0, this should be just that. Okay. Otherwise, so the first card has 4 matching numbers. So that means the 2, 3rd, 2nd, 3rd, 4th, 5th should all increment. They got a multiplicity. Okay. So that's right so far. And what is wrong here? This is so this means 2, 3, 4, 5, 6. This is second line happens once, third line happens twice. No, this is not right. Something is wrong. Yeah, I need to finish this. No more coffee. You don't need the extra bracket. Why do you do that? Much better. You need Oh, you forgot to count itself. That's right. So you here you forgot to count itself. Fucking idiotic. So whenever you process a card, you need to count itself. That's right. So if you are on the first line, let's see, we don't need the multiplicity list. Remove that. So for example here, you need to, for example, the first line, 4 matching numbers. That means you need to return a list that is 1, 2, 3, 4, 5. Why 1, 2, 3, 4, 5? Because 1 is a line itself. Then 2, 3, 4, 5 is the next 4 lines index. So the second line is 2. They should return 2, 3. 2, 3, 4, not 3, 4, because you need to wait. Okay, I see what's going on. Yeah, so okay, so let's not, so yeah, so I have kind of Yeah, you don't include itself, because the original copy is always count. You just add the total number of lines, to your solution. So don't generate itself here. So in that case, when it's equals to 0, what do you do? Let's see. That's better. Do not include itself. Now what about 1, 2, 3, 4? The fourth line. 1, 2, 3, 4 is 1. 1 means include the next one, 5. Okay? Yeah, so this is better. So don't do the if. Okay? So once you have that, then what's next? Then you tally and flatten. Then you multiply. So this means the result here means on the second line you have 2 multiplicity. On the third line you have one more. On the what? On the first line. Wait, what? Yeah, God. Yeah, okay. So on the second line, you have only 1 multiplicity. On the third line, you have 2 multiplicity, not counting itself. So once you get this, you want to let me do this. $14. So the answer is 14 plus the number of lines. 1, 2, 3, 4, 5, 6. So which is 20, which is incorrect. It's supposed to be 30. What? Multiplicity. Let's check. Let's read. Concurrent viewers 6. God. Card 1 has 4 matching numbers, so you win 1 copy each of the next 4 cards. 2, 3, 4, 5. Oh, you need to take the second. Shit. Okay, so you gotta do this again. That. Now 9 plus 6 is wrong. What the fuck is this problem? Your copy of card 2 also wins 1 copy each cards of cards 3 and 4. Your 4 instances of card 3 have 2 matching numbers, so you win 4 copies. What? Your 4 instances of card 3. Oh, so there's a multiplier somewhere. So your 4 instances of card 3. So you have 4 instances of card 3. Okay? Card 3 has 2 matching numbers. So your 4 instances of card 3, you have 4 instances of card 3 because you have card 3 has itself a copy, original copy, plus you won it twice before. So you have why 4 instance of copy of card? Did you use set intersection 2? Yeah, that's you can see the solution to the first problem here. Okay, that's a solution to the first problem. But we are trying to solve the second problem. The second problem, you see the intersection is here. You know, that's this XX. So that gives us already, so we already have the winning count. Yeah, so okay. So but now the issue is with this multiplicity. So it says your 4 instances of card 3. So card 3 has 4 instances. Why is that? Card 1 has 4 matching numbers, so you win 1 copy each of the next 4 cards. 2, 3, 4, 5. Okay? Your original card 2 has 2 matching numbers. Okay? Card 2 has 2 matching numbers. So you win 1 copy of each card 3 and 4. That's right. Your copy of card 2 also wins 1 copy of each of card 3 and 4. Oh. What? Your copy of card 2. So card 2 gets you card 3 and 4, wins you card 3 and 4. But for each copy of card 2, you have 3 and 4 again. Okay, so this number needs to multiply Okay, so I got it close. So each instance of the card. Let's summarize the problem again. So you have a bunch of cards. Each card is numbered 1, 2, 3, 4, 5, and so on. For each card, you have the matching number. A count of matched number. For example, card 1 has 4 matched number, card 2 has 2. And for each card, you have the concept of multiplicity, which means basically a total instance. You know, in Elf's jargon, it's an instance of number of instance you have. So the concept is multiplicity in mathematics. So here we list the card. So let's see, should it include itself? So then we map indexed. It should include itself. Okay. So it's not total. You see these two. You see this 2 1. 2 needs 2 plus times 1. 3 needs 2 times 2. Wait. What is this multiplication? So each card has multiplicity. So your copy. So what is you need to you need to re-evaluate. Okay. Oh, so you solve this problem. Thiago, a card that won wins more cards. I used recursion for this. You need to re-evaluate each new card too. Yeah. You know, I think this works. We just need to I'm getting tired. We just need to multiply them together. You know, so I'm not using recursion myself. I use the index number for each. But do I have to? Wait, so unless I actually solve the problem, so I can't be sure. So what is the issue here? So each card has a multiplicity, right? Yeah, copy of card also wins one copy of each card 3 and 4. Your 4 instance of card 3. Your 4 instance of card 3. I only got 2 instance. 2 plus 3 original itself. So I only have 3 instance of card 3. So here it says your 4 instance of card 3. 1 original and 3 copies. With fucking stupid problem. Your original card 2 has 2 matching numbers. So you got card 3 here. You won from card 1. Then you won card 3 again from card 2. So you won card 3 twice plus the original copy. So you have 3 instances of card 3. Yeah, well, but it says 4. Well, it's because your copy of card 2 also wins 1 copy each of card 3. And so your copy of card 2, which give us 3, 4. So now, okay, so you need to process this, yes, recursively once you got this list. So we can use reduce. So for example, the first card gives you 2, 3, 4, 5. Then the second card gives you added 3, 4. So the first card, in other words, the first card gives you 1, 2, 3, 4, 5 card number. The second card gives you 2, 3, 4. The third gives you 3, 4, 5. Okay, but however, when you count the multiplicity, oh shit, this 2, 3, 4, 5. Ah shit, I'm getting tired and this is getting too long. Maybe I should stop. Stop or continue? Those 11, now it's 11 people watching. Should I stop or should I continue? But I need to take a break though. Fuck. if I continue, I need to take a break, 5 minutes, 10 minutes. I think I should stop. Let's see, who is talking in Discord? Nobody. Yeah, take a break. Okay, Lunita says, thank you. 2 hours is too much. Hello, I'm new at coding high school. How can I improve skills? Should I waste all my time as coding? Right now I have a holiday. Yeah, okay, so I think I'm gonna stop because it doesn't make sense just watching me sitting here do nothing. I mean, it's too bad I didn't finish problem 2. Problem 1 is so easy. Problem 2 is very close. I mean, I can do this very, very close. Day 4, problem 2, very close. Okay, so yeah, but I'm tired. Doesn't make sense to continue because if I continue, I need to take a break and 10 minutes walk. Yeah, so it's better to stop. Yeah, install Gentoo. That's the way to go. Okay, bye guys. Thank you guys for watching.